Hello students, let us start with the concept of propositional logic. Now when I say the word proposition, so what is the meaning of proposition? See, in mathematical theory, assertions are made in form of sentences. Such assertions are called statements or proposition. Or in a simple language, if I want to express, I say a proposition. A proposition is a declarative sentence. It is a declarative statement. Okay, it is a declarative statement which can be either true or false, but not both. So it has to be either true or false. For example, if I say the sky is blue, so that is a proposition. The sky is blue. So I will say yes, it is a declarative sentence which has the answer yes or no, or in maths we say 1 and 0. So it is usually represented by the small letter. Now if I say what is the color of sky? So it is not a proposition because it is not a declarative sentence. Same way if I say 2 plus 2 is equal to 4. It is a declarative sentence which has a truth value yes, true or 1. If I say 2 plus 3 is equal to 4, then it is also a declarative statement which is false, right? Now if I tell 2 plus x is equal to 5, now this is not a declarative sentence because I don't know the nature of x. So this is not a declarative sentence. Now what is a exactly if I try to break these two words? So what is a proposition? Sorry. The proposition is a statement which can be either true or false, but not both. And logic means reasoning. So basically, when I talk about propositional logic in discrete mathematics, I talk about the reasoning and the logic. It has a vast application in engineering as well as in the other field. If you have seen the puzzles of knights and knaves, it can be sorted by using this concept. Same way in algorithm check, algorithm flow also it is useful. In digital circuit design also it is required. Logic gates concept, Boolean algebra, control system, robotics, automation, software engineering, everywhere this concept is used. Okay. So now as I said, a declarative sentence is proposition which has the value true or false. It is usually represented by these alphabets. Okay. Now when I write a simple alphabet like the sky is blue, okay, or 2 plus 2 is 4, or 3 is a odd number. So these are the simple proposition called the primitives. Now suppose if I want to join them. So to join them I need connectives which are known as logical connectives. So I have few logical connectives. Let us start with that. Now when I am talking about logical connectives, the very first logical connective is called conjunction. It is represented by this and its basic meaning is and. Okay, it is a and operation. Now, if I try to understand the basic behavior ki how this conjunction works to form the compound proposition, see it works like that. Suppose I am taking two proposition P and Q. Now, what are the possible values of P? 1, 1, 0, 0. 1, 0, 1, 0. Right? So now if I want to make P and Q. So P and Q, when it is 1, this is 1, so it is 1. Means it will take the value true or 1 only if both the propositions are true. So here it will be 0, here it will be 0 and here also it will be 0. The second proposition I have is disjunction. Disjunction is represented like this and it is called or. When I say or, it means any one of them or both. So if I try to make like this. So when both are true, it is true. When one of them is true, it is true. So I will have only 0 here. There is one more which is called exclusive disjunction. Now what is the meaning of this exclusive disjunction? It is represented like this or this. This means either P or Q, but not both. So if I draw here like this, so here see, both are true. So this will not be true, this will be 0. Okay, and here 1, 1 and 0. See, when you make or connect it with some example, you will not forget. I'll tell you a simple example. Suppose I am taking an exam, or suppose your parents told you that if you score good in exam, they will gift you a car or they will take you for a foreign trip. Now when I am talking about or, suppose you scored good in exam. Now if they are giving you a car or a bike, you are happy. If they are taking you for a foreign trip, you are happy. But suppose if they say, okay, let us go for a foreign trip and then we will give you a bike. Will you mind it? No. So you are happy. Okay. So this is a case of or. Now when I talk about exclusive disjunction, so it is like that ki your parents has told you to do certain works. They have assigned you certain works. So they are saying ki either you do the cleaning of the house or you help in kitchen. So if they ask you only to clean the kitchen, do the dusting of the house, you are happy. If they ask you to help in kitchen, you are okay. But now if they ask you to do both the things, you will make the faces na. So this is false. So this is how you should remember the truth values. Then only you can do the questions. Now this way when I work, this is called the truth table. Now what is the fourth connective? It is negation. Negation is represented like this. And its basic meaning is not. Okay. So if I want to write negation of P, so for 1, I should write 0. For 1, I should write 0. For 0, I should write 1. For 0, I should write 1. Negation Q will be 0, 1, 0, 1. Just opposite of this Q. Right? Now, after negation, we have implication. Now, this implication is very nice. Okay. Now, implication, if I say, it is represented like this. It is also known as conditional. And it is also known as if then. So now if P values are this and Q values are 1, 0, 1, 0 and I am talking about like this. Now see how to remember this. Suppose P represent you prepared for the exam and Q is your result in exam. Now you prepared and you passed. You are happy? So give 1. Now you prepared for the exam but you flunked. You are happy? No. So put 0. Now you never prepared for the exam but you passed. You are happy? Of course, why not? Now you never prepared for exam. You never passed. You are happy? Yes, because Sachin Tendulkar don't need to pass an exam. Na? He is happy in his life. Same way, you are not interested in that. So this is how you need to remember this. So you make your own story and connect it. It is not important that you should remember what I am telling. Make your own stories to remember it. Now, what is the sixth one? Sixth one is biconditional. Biconditional is represented like this. Okay. This means if and only if. Or IFF. Or necessary and sufficient. So when I say like this, it will be true when both the values are same. So 1, 1 is 1 and 0, 0 is also 1. Okay, and remaining 2 will be 0. Correct? So this is called biconditional. So this is how I can make the table for all the connectives. Right? Now suppose if I am giving you any compound proposition and you are making the truth table for it. Okay? So I can have three things. First thing, my final answer will all have true. Other one, my final answer will all have false. 1 or 0. And other, there will be mixture of true and false, that is 0 and 1. So in this case, it is called tautology. Okay? Here it is called contradiction. And here it is called contingency. So usually they give the questions ki show that it is a tautology, show that it is a contradiction, show that it is a contingency, and one more thing which they can ask is logically equivalent. They will give a big proposition here, they will give a big proposition here. What you have to do, write down its truth value, write down its truth value. If both are exactly same, then it is logically equivalent. Or if you make a column of this, okay, so when they have the same values, you will get 1, 1, 1. If this is a tautology, then it is logically equivalent. Or you can finish it over here also. Right? So this makes one question, ki show that it is a contingency, it is a tautology, or it is a contradiction. So that create one questions. Right? Now, suppose I have this type. I'll give you one simple example. Suppose I have, say, P and Q. Okay, a negation of P and Q is logically equivalent to negation of P or negation of Q. Suppose this is a question. Okay, now how I will do it? What I'll do, I'll write P, I'll write Q. Now what I need negation P, negation Q. So I'll make negation P, I'll make negation Q. I also need P and Q, so I'll make P and Q as well. Then I need negation of P and Q also. So negation of P and Q also I'll make. And then I need negation P or negation Q also. So this also I make. Now suppose this is your U and this is your V. So last column I'll make U logically equivalent to V. Or directly I can compare also. Okay. I can name this column as U and this column as V. Now let us start. 1, 1, 0, 0, 1, 0, 1, 0, 0, 0, 1, 1, because opposite of this, 0, 1, 0, 1. Right? Now when I'm talking about AND, I know that this will take positive value, 1 value, only if both are 1. So 1, 1, 2, 3. Correct? Now negation of this is opposite, so 0, 1, 1, 1. Correct? Now come to this one. Now negation P or negation Q. So I have to compare this and I have to find OR. And if you remember, OR means it will take one value if either one of them is 1. So first is the 0, 0. So I'll get, see, first is 0, 0. So I'll get 0 only. 0, 1 will give me 1. 1, 0 will give me 1. 1, 1 will give me 1. Now see, U and V have the same truth values. So they are logically equivalent. Or at the end, if I make this column, see, they are same 1. They are same 1, 1, 1. So it is a tautology. So it is logically equivalent. So this is how they construct the question and they ask you to prove. Right? So this type of questions are very common for exam. Now let us see few more questions. Now before doing few more questions, here one basic thing you observe. When I take the two proposition P and Q, and I know each proposition can take two values, 1 or 0. So how many rows I got? I got 4, means 2 to the power 2, because two proposition and each proposition can take two values. Now if you have P, Q, R, so what I'll have? 2 to the power 3, means 8 rows I'll have. If I have P, Q, R, S, so 2 to the power 4. So this will give me the number of rows. Okay. Now look at this one question. Now suppose I am saying कि P says that A is a conic. Okay. and Q says that 3 is a real number and R says that series is convergent. Correct? Now tell me how you will read this. So how I will read this? See, this is and this is negation of Q. So what is P? A is a conic. So what I will say? A is a conic and 3 is not a real number. So I read this as and this as not. So this is how you should learn how to do it. Okay. Now if I say negation P or Q. So how you will say? A is not a conic or 3 is a real number. Now if I write like this, P or negation Q. How you will read this? A is a conic, either A is a conic or 3 is not a real number. Because of this exclusive, I say either A is a conic or 3 is not a real number. Okay. Now if I say Q implies negation P, how you will read this? If 3 is a real number, then A is not a conic. If, because this is conditional, if 3 is a real number, then A is not a conic. Okay, so this is how you have to do the question. Let us see few more with the same statements. Okay, I'll write here only. Now suppose I am giving you P implies Q and this. So how I will read this? The moment conditional come, I should start it with if. So if A is a conic, then either 3 is a real number or series is convergent. Because of this, I am using either or. Okay, again listen. If A is a conic, then either 3 is a real number or series is convergent. Now if you have this thing, how you will read this? A is a conic if and only if 3 is a real number. Sorry, A is not a conic if and only if 3 is a real number. So this is how we can construct the sentence. Now you can practice a lot of questions where you have to prove that it is a tautology, it is a truth table, it is a contradiction and all. Now let me show you one different type of question. Now suppose if I am saying P implies Q is a false. So find P and Q. So immediately you have to go back to your table of conditional. So if you remember how I told you 1 1 0 0 1 0 1 0. Now if I want to make the table for this, I studied, I passed. I studied, I flunked. I never studied but I passed, I am happy. Never studied, never passed, I am happy. So when this statement is false, this statement is false here. Correct? And when this statement is false, your value of P is 1 and the value of Q is 0. So this is your answer. Most of the time this conditional and comes in this type of question because we know that they take a different value only once. Okay. Now, how I can frame one more question? P implies Q is false. Okay. Find the value of negation P or Q. Okay. How I will do this question? Now, the moment I say P implies Q is false, means P is 1 and Q is 0. Now, if P is 1, negation of P is what? 0. Okay, and this is OR. Q is also 0. So, I'll get 0. So, the value of this is 0. Same way, what is the value of Q implies P? Q implies P will be 1 because you never studied but you passed. Right? Now if I talk about negation Q implies negation P. So negation Q means what? 1. So you studied and you are failed. So you are not happy na? So 0. So this is how you can do the question. Let us do one more question like this. Now you have to find out PQR given that P implies Q or R is false. Now again conditional is false only in one case, when you studied but you failed. Means P is the one you studied but you flunked. Means Q or R is equal to 0. And we know that Q or R is 0 only once when both the values are 0. So Q is equal to 0 and R is equal to 0. So this is my answer. Simple. Now do this one. P and Q implies R is true. Now we know that conjunction is true only when both the parties, both the proposition are true. Means P is 1 and Q implies R is also 1. Now P is 1, so I got one answer. Q implies R is 1 in 3 cases. What are those 3 cases? I studied, I passed. I never studied, I passed. I never studied and I never passed. So in all the 3 cases I get 1. So these are the possible combination of your answers. Okay. Now look at one more. Now find out P, R and S. Given Q is equal to 1 and Q implies, this is pretty big, so carefully you have to observe. So I have Q implies negation P or R and negation S and negation S implies negation R and Q is true. Okay, so if you observe, I can break it into 2 parts, this and this. And in between I have conjunction. So I know that this will take the value true only in one condition, when both are true. So separately I can say that this part is true and this part is also true. Now one by one I will solve both the parts. Okay, let me start with the small part. Negation S implies negation R and Q is true. Now if this is true, so this is true in 3 cases. So this will to create problem for me. Okay, so what I will do, I will go on the other side. Because I need some basic work, basic information. Only I know is the Q is 1. So now let us start with this. Now see, this is happening. Now when I am saying Q implies negation P or R and negation S. Okay, this is true. So I know that conditional is true in 3 cases. But I also know that in the beginning it is 1, means I have studied. So when I will be passed? Only when I passed, right? Then only I will be happy. So this thing has to be 1. Right? Remember, if P implies Q is 1 in 3 cases. What are the 3 cases? 1, 1. Okay. 0, 0 and 0, 1. So 1 is there only in one condition, right? Q value they have given 1. So this value has to be 1. Then only it can be true. So now when I am saying that this bracket is true and in between there is and, means this is true as well as this is true. So negation S is 1. So what is the value of S? 0. Same way negation P or R is equal to 1. Okay. Now there is a problem. Or can have one value in 3 cases. What are those 3 cases? Either negation P is 1 and R is 1. Negation P is equal to 1 and R is 0. Negation P is equal to 0 and R is 1. In all the 3 cases, this thing 1 is true. So I will keep it on hold. And I will go this side now. Now I know that negation of S is 1. The moment this is 1, this has to be 1 for being true. So negation R and Q is equal to 1. And is true when these two are true. So negation r is equal to 1 implies r is equal to 1. Sorry, r is equal to 0 and q is equal to 1. So now go here. Where you have r is equal to 0? This place only. So means negation p is 1. Negation p is equal to 1 means p is equal to what? 0. Answer. So I got my all the answers. Right? So this is how you have to do. Even if it is big, you just think and work on it. You will definitely get the answer. Okay. Now let us see one more question. Now you have to prove tautology. One question we have done. So I will do one question for logically equivalence, right? So now you have to show that U is equal to P or Q implies R and V is equal to P implies R and Q implies R are logically equivalent. Okay. Now as I said, when you have P, Q and R, so 3 proposition. So 2 to the power 3 is 8. So I will have 8 rows. So 1, 2, 3, 4, 1, 2, 3, 4. 1, 1, 0, 0, 1, 1, 0, 0, 1, 0, 1, 0, 1, 0, 1, 0. So this way I'll get all the possible combinations. Right. Now what I need to make? I need P or Q. Then I need P or Q implies R, which is my U. Then I need P implies R, this one. I need Q implies R. And then I need V. V is nothing but P implies R and Q implies R. 2 parts. Correct? This is your V. So logically equivalent means these two columns should be exactly same. So let us quickly do it. 1, 1. See, I am checking these two P and Q rows, columns. 1, 1, 1, 1, 0, 0. Okay. Now this implies R. So I studied, I passed. I studied, I flunked. I studied, I flunked. I'm not happy. I studied, I passed. I studied, I flunked. Not happy. I studied, I passed. I'm happy. I studied, I flunked. I'm not happy. Never studied, I passed. Happy. Never studied, never passed. Happy. Right. Now I'll do P implies R. Now 1, 1, 0, 0, 1, 1, 1 and 1. Now Q implies R. So now I'll compare these two columns. So 1, 0, 1, 1, 1, 0, 1, 1. Now I should take AND of these two columns. See here. So 1, 0, 0, 0, 1, 0, 1, 1. Now you have to check this and you have to check this. Wow, super. Ours is not coming logically equivalent, means somewhere I have done a mistake. Right? So now let us try to catch our mistake. So this way, if you are doing a mistake, you should cross check, because when they are saying it is logically equivalent, it is logically equivalent. Okay. See, this is correct, same. This is correct, same. This is correct, same. Same, same. So here only I can see the problem in the third one. So let us check the third one. Okay. Now from here I'll start. P or Q. So 1, 2, 3. See here, it is 1, it is correct. Now P or Q implies R. I studied and I passed, correct. So this is so correct. Now I should check here. Now P implies R. So when I'm saying P implies R, see, this is 1. I think I cross-checked the wrong columns. I was checking these two columns rather than these two. So I got 1. Okay, so I will rewrite this column because I am feeling that this I compared first two columns rather than first and third column. So let me reconstruct this column. So now again see, I am comparing this one and this one. Okay, so I studied, I passed, I am happy. I studied, I flunked, I am not happy. I studied, I passed, I am happy. Studied, not passed, not happy. Not studied, pass, happy. Not studied, not pass, happy. Not studied past, happy. Then again happy. Other one is Q implies R. So let me quickly check this also. This is correct. This is correct. This is correct. This is correct. Correct. No, correct. Correct and correct. Now these are correct. Now you need to check and. So 1 1 is 1, 0 0 is 0, 1 1 is 1. See now, I got the same, it is logically equivalent. So this is the beauty of these questions, immediately you can catch your mistakes. So now what you should practice, a lot of proposition you should take, and you should check about the tautology, you should make the truth table. That is the easiest thing to do. I hope you understood. Please subscribe the channel so that whenever I am updating the new topic, you will get the notification. Thanks a lot.